Every day I wake up at 4 a.m. to solve a math or physics or computer science or a chemistry problem to inspire you to fall in love with math and science. Today we're gonna solve a physics problem. So let's get started. A projectile is fired with let's say 35-degree angle. 35-degree angle. A projectile is fired with 35-degree angle horizontal with 20 meter per second with the velocity 20 meter per second. Now what I want you to do, I want you to find the range. Find the range. There are two ways we can find range, and I'm gonna teach you both ways. The first one is super easy and the second one is a little bit complicated. So let's do the first one and then I show you the second one. The kinematics equation, one of the kinematics equation is very handy. Is look like this. D is equal to half VIT plus half AT squared. Now this kinematics equation has two components. One is toward the x direction, one is toward the y direction. So let's divide this kinetic equation into part. The x direction and the y direction. So I'm going to move the camera a little bit this way. Alright. So the y and the x. The y should look like dy. This one, if you picture this, let's draw a picture for this one. So a projectile fired 35-degree angle with 20 meter per second. So 35-degree angle. This is 35 degree. And this is 20 meter per second. 35-degree angle, 35-degree angle, this is 35-degree angle. And how fast? 20 meter per second. Now, a range is this one. This is what we try to find, the range. The range is how far it is landed from the origin. It was fired at right here. And it landed right here. So we try to find the range. And one thing you should remember in projectile motion, that the x component of the velocity is always constant. What do I mean? Here's what I mean. This one, let's take this one over here, put this one over here. Vx. So velocity has two components, Vx and Vy. Vx is always constant. What do I mean by constant? The constant means it never changes. Not even at the top where it changes the direction. So Vx always remain same. The x component of the velocity never changes. Now let's see the y component of the velocity. Y component of the velocity changes is because the acceleration due to gravity has two components, ax and ay. Ax is 0. You see acceleration due to gravity at the x component is 0. This is why velocity at the x direction is unchanged, is constant, because acceleration at the x component is 0. But acceleration at the y component is negative 9.8 meter per second squared. How will that affect the y component of the velocity? It affects, this is the y component of the velocity. y component of the velocity is getting smaller and smaller and smaller, and here the y component of the velocity is 0. And right here the y component of the velocity is equal in the magnitude but opposite in direction. So as you see that the second way, what we're gonna do, we're gonna use the velocity initial at the y direction is equal to velocity final at the y direction, which is equal in magnitude but opposite in direction. That's the approach we're gonna use. But now we're gonna use this approach. But from this graph, you understand one thing is that the x component of the velocity is always constant, but y component of the velocity is keep changing is because of acceleration due to gravity, and the y direction is 9.8 meter per second square. So let's come back over here, unless it is this. What we're gonna do here, we're gonna write the y component of this kinematics equation. So dy is VIYT plus half AYT squared. And now we're gonna write the x component of this one. The x component of this one is dx is equal to VIXT plus half AXT squared. Alright, let's deal with this one first. Dy is 0 because we're trying to find the range. VIY is, you probably remember that the B has two components, Vx and Vy, and Vx is V initial cosine theta, and Vy is V initial sine theta. So this should replace by V initial cosine theta. So let's do that. Replace it by V initial cosine theta. V initial cosine theta times t plus half acceleration due to gravity at AY has another name. G is constant. So we're going to replace AY by G and t squared. Great. It looks now simpler and nice and elegant. What can we do with this one? We can factor out t, as you see that. So let's factor out t and let's see what happened. T. So Vi cosine theta plus half gt. Alright. Now we can divide both sides by t, and let's see what happens when we divide both sides by t. Alright. This is 0. This cancel out. So what are you left with? Vi cosine theta plus half gt is equal to 0. Now we have to isolate t because we want to derive an equation, an universal equation that can solve range problem pretty quickly. That's what we want to do. So let's isolate t. How can we isolate t? Very simple. Half gt is equal to Vi cosine theta. Don't forget to put a negative here. Alright, now multiply both sides by 2. So gt is equal to negative 2 Vi cosine theta. Now divide both sides by g. Now remember, g is a negative value, negative 9.1. We're going to make it positive by absolute value. So t is equal to negative 2 Vi cosine theta over negative g. So negative cancel. So what we're going to do, we're going to write absolute value g, obviously, because we make it absolute by removing negative part from it. So 2 Vi cosine theta. Alright. So alright. So let's see what we can do from this side. Alright, so dx is obviously dx will remain, is because the dx is something that we are trying to find, because this is called dx or range. Okay, so Vix can be replaced by, oh, this is Vix completely. This would be this is Vy, so this should be sine. This should be sine. So this is Vy, so this should be sine. So this is sine theta. This should be sine theta. And this should be sine theta. and this should be sine theta, and this should be sine theta, and this should be sine theta, and this should be sine theta. All right. Why this has to be sine theta? Because look, I wrote Vy is sine theta over here, and I made a mistake over here. It can happen, especially when you wake up 4 in the morning to solve physics problem. Okay, hopefully I fixed it. If I did not fix it, I will be able to kind of figure that out. The math is so powerful tool that you would be able to figure it out before, along the problem solving. You should be able to figure it out if you make mistake, and you troubleshoot it, you fix it. We just fix it. Now we're gonna do dx component. So dx Vix should be replaced by Vi cosine theta times t plus ax. X component of the acceleration is 0, as I explained it before. So x component is 0. All right, great. So this is what we left with. Great. Now, as you see that t is 2vi sine theta over absolute value of g, we're going to replace this t by that. All right, if we do that, what do we get? So this t would be replaced by this whole thing. So we have Vi cosine theta, and t is what? 2 Vi sine theta over absolute value of z. Now we're gonna isolate. What can we isolate? We can put cosine and sine together. So dx is Vi, and Vi is obviously Vi is square over absolute value of g. Great. Now what we can do, we can put 2, this is 2, so you're gonna write 2 sine theta and cosine theta. And by definition, 2 sine theta and cosine theta is what? 2 sine theta and cosine theta is sine 2 theta. Okay, so you're gonna replace it by sine 2 theta. So dx is Vi squared over absolute value of z sine 2 theta. Now we should be able to solve this problem. We see that our angle is 35. So, and our initial velocity is 20. So V initial squared means 20 squared, which is 400. Absolute value of g is always positive, so we're gonna put 9.8 times sine 2 theta means you have to double the angle, so sine 70 degree. Now we're going to take our calculator and let's see what we get. Alright, so sine 70 degree is, let's see, sine 70 degree is 0.93. 0.93 times 400 is 375 divided by 9.8, and that's 38. So 38.35. So it's about 39. Is about 30. Yeah, it's about 38 meter. Yeah, 38 meter. Yes. So it's about 38 meter. 38 meter. So the ball landed. You saw me how I fix it. If we one of the important thing is the math allow you to see your mistake and also allow you to fix it. We found that the ball landed 38 meter away from the origin. 38 meter away from the origin. So the ball landed here, which is 38 meter away from the origin. Now we can solve this problem a little bit different way, which I call a dummy version. For dummies, physics for dummies. Okay, so physics for dummies will allow us to solve. This is pretty simply. This problem pretty simply. Okay, so this is the dummy version. So our problem is, here is our problem. Our problem is you fire a projectile. If you fire a projectile, what do you see? You fire a projectile, the projectile will come back. Is because of course you're not gonna the velocity you applying 20, not 12,000. If you apply 12,000, then that is little bit over the escape velocity. Then it will never come back. But since you apply only 20 meter per second at 35-degree angle, it obviously come back, making it a projectile. So 35-degree and 20 meter per second. So here's how the dummy version look like. It's pretty easy. So as I explained, I'm going to take this one and put it here, over here, and I'm going to put, this is Vx, this is called Vx, that x component of the velocity, which I explained a little bit before. Vx, and Vx never changes at x, velocity as x direction never changes, but velocity at the y direction keep changing. So Vy is 0, Vy, and then this is Vy. Alright, this Vy and this Vy are same in magnitude but opposite in direction. That's the factor you're gonna use it right now. So velocity, as you know, that two component. The first component is the x and second component is the y. So you're gonna write 20 cosine 35-degree and 20 sine 35-degree. So let's see what is 20 cosine 35-degree is. Cosine 35, which is 16.38. Let's see, sine 35, 11.47. Okay, so velocity has two component, x component and y component. X component is 16.38 and y component is 11.47. What can we do with this one? We can do many things. We can take the y component. The y component is, what is the initial y component? Initial y component is 11.47, obviously. So this is 11.47. This is Vy initial is 11.47. Okay, and Vy final is negative 11.47. Negative 11.47. So what are we gonna do? Vy is negative 11.47. Okay, and minus 11.47. So what do we get? Times 2, and we get 22.94. 22.94. Of course, this is negative. This is negative. Okay. So, or you can, yeah, this is negative. Okay. So what can we do now? In step 2, you can find the Vf square is equal to Vi square plus 280. Alright, let's see what can we do. Before we do that, I think we should find the time, and the time is, let's see how we can find the time. A is, I guess, let's see, A is acceleration is velocity over time. So then velocity is negative 22.94. Well, acceleration is velocity over time. Then the time is velocity over acceleration, and we should replace A by G. So then time is velocity over G. So the velocity is negative 22.94 and G is negative 9.8. Let's see our calculator. 22.94 divided by 9.8. Let's see what we get. We get 2.34. 2.34. Now what can we do with this 2.34? We can write the equation d is equal to VIT plus half AT squared. Of course we're going to do it at the x direction because we try to find the range. So x direction, and x direction, the acceleration due to gravity at x direction is 0. So you're going to let it to the 0. So d is equal to VIX, and VIX is 16.38 times t is 2.34. Let's see what we get. Times 16.38 is 38. So we get 38 meters. So this is simple way, but this is a dummy version. But I want you to try this way. First, I want you to kind of derive an universal formula. What was the universal formula that we derived? This was the universal formula we derived. This was the universal formula we derived. I'm going to highlight it in different color. This was the universal formula we derived. Dx, any range problem, if you use this formula, you should be able to find the range, and that is b initially squared over absolute value of g to v initially squared absolute value over g. This is simpler version than that one. V initially squared over absolute value of g sine 2 theta. Thank you for watching. Don't forget to fall in love with physics.